4.2 goes over the number e. Your number e is defined as a value that is that 1 plus 1 over n to the power of n, where as n becomes large, it becomes larger, like the actual value of it becomes larger. Your e is an irrational number, so it's like pi, where you can't necessarily represent it as a specific number, which is why we represent it as e. E is approximately that 2.718218, and so on and so forth. Okay, so again, you'll represent it as e. You'll also need a calculator for this section, just like you did with the section that we did before it, because we are going to be evaluating these. So a lot of times you'll see these as functions. They look very similar to exponential functions. Why? Because your variable is the exponent. So these functions will look just like you would have something like g of x is equal to 2 to the power of x. So they're the same type of function because your variable is the exponent. So all of these graphs are going to have an asymptote, and they're going to curve either going up or going down. Okay, if we look at these three different graphs that are drawn for us, we have y is equal to 3 to the power of x, we have the graph of y is equal to 2 to the power of x, and we have the graph of y is equal to e to the power of x. Do you see how they all look very similar? The only difference is exactly where those ordered pairs on the line are. So they are all the same type of line because they all have that variable as an exponent. If we look at example 1, we're just asked to evaluate each expression and round to 5 decimal places. So again, you will use your calculator for these. For example A, we have e to the 3rd power. So on your calculator, if your calculator is like mine, you can hit that second button and find the ln button, and it should give you a power of e to the power of x. So if you press that, it's going to automatically prompt you to put in an exponent on e. If you just put 3 and hit enter, it'll give you the number 20.08553692. If we're rounding to 5 decimal places, that's that 3. So this is 20.08554. For example B, we have 2 times e to the power of negative 0.53. So with this one in our calculator, we'll type in 2, the second button, find the ln button to get that e, and then it prompts you for the exponent on e, which is negative 0.53. Hit your enter button, and it gives you the number 1.177209939. Again, we're rounding to the nearest, or the 5th decimal place. So 1, 2, 3, 4, 5, that's at 0. That 9 is greater than 5. So this turns into 1.17721. For example C, we have e to the power of 4.8. So again, we're going to find that second button, the ln button, press the second, then ln. Then it prompts you to put in the power on e, which is 4.8. Hit your enter button, and it gives you 121.5104175. If we're rounding to the 5th decimal place, that's that 1. So this is 121.51042. For the next part of our lesson, we're working with a formula that involves E. It tells us that an infectious disease begins to spread in a small city of a population of 1,000. After T days, the number of people who have succumbed to the virus is modeled by the function V of T is equal to 10,000 all over 5 plus 1,245 times e to the power of 0.97 times t. A asks us how many infected people are there initially. Initially means that no time has gone by, so T would be 0. So if we plug in 0 for this, we would have V of 0 is equal to 10,000 over 5 plus 1,245 times e to the power of 0. Now, anything to the power of 0 is 1. So we could literally just do 10,000 divided by, I would put parentheses around what you're going to put in next, 5 plus 1,245 times e to the power of 0. Close your parentheses off and you get 8. So V of 0 is 8, or 8 people. For our next example, for B, it tells us to find the number of infected people after 1 day, 2 days, and 5 days. So we'll first do V of 1. So V of 1 is going to be 10,000 over 5 plus 1245 times e to the power of negative 0.97 times 1. We plug this into our calculator. We have 10,000 divided by parentheses 5 plus 1245 times e to the power of negative 0.97. Close the parentheses. We get 20.9661896. Now, you got to think with this. We're working with people. Can you have 0.9 of a person? No, you can't, so round it to the nearest whole number. So V of 1 is going to be 21 people. Next, we're going to find the amount of people that are infected after 2 days. So we're going to plug in the 2 for T. So this is going to give us 10,000 over 5 plus 1245 times e to the power of negative 97 times 2. So V of 2, use your calculator, 10,000 divided by 5 plus 1245 times e to the power of negative 0.97 times 2 gives us 54.3740319. Again, we got to round to the nearest whole number, so V of 2 is 54 people. Next, we'll find how many are infected after 5 days. So we're going to have V of 5 is equal to 10,000 divided by 5 plus 1245 times e to the power of negative 0.97 times 5. So V of 5. So we plug this into our calculator. 10,000 times, divided by 5 plus 1245 times e to the power of negative 0.97 times 5 gives us 678.1348286. We round this to the nearest whole number, and after 5 days, 678 people are infected. For the last part of our lesson, we are working with interest that is compounded continuously. We are going to be using the formula A of t is equal to PERT, or P, your principal, times e to the power of your rate as a decimal times your time in years. So again, just like we did in the lesson before this, t is in years. So if it's giving you 6 months, that's half a year, you would use 0.5 or 1/2 for t. For our last example, it tells us to find the amount after 3 years if $1,000 is invested at an interest rate of 12% per year compounded continuously. This compounded continuously means use the formula A of t is equal to principal times e to the power of your rate as a decimal times your time. So, your principal is $1,000. The rate, the time, let's do the time, is 3 years. T is 3. And your rate is the 12%, which is 0.12. We plug this into our formula. A of t, we're doing 3 years, so that's A of 3, is equal to our principal, which is 1,000, times e to the power of our rate as a decimal, so 0.12, times t, which is 3. We're going to use our calculator. We have 1,000 times e to the power of 0.12 times 3. We get 1433.329415. We are working with money, which means round to the nearest hundredth. So A of 3 is $1,433.33.